Okay, let's just straight to understand how we get to apply implicit differentiation to exponential functions. Okay, so if you look at this case, we have this is our function, and then of course we want to determine the derivative, of course, in respect to x, dy dx, y respect to x. Okay, so we know the basic standard of differentiating a function. Some of the basic things that I would have to remind you is if you're differentiating a term x to the power 3, all you just have to do is multiply the power by the coefficient, okay? So there's a 1 there, 3 by a 1 gives us a 3, and then the power would have to reduce by a 1, so it becomes 2. That's how we differentiate the normal functions. Okay, now I would have also to remind you to say if you have a constant, constants of course becomes zeros, and then of course let me talk about the exponential. So if you have e to the power x, its derivative is what? Multiply the original function by the derivative of a power. So you agree with me that the derivative of x is 1, so the derivative remains the same. Now the moment I put, let's say, let me put 2x. Now I'm saying the derivative of an exponential function is multiply 2, right? So multiply the derivative of a power to the original function. So the derivative of 2x is 2, so we have 2e to the power 2x. So that is how we differentiate the exponential functions. Now, with the understanding of the basic differentiation and of course the exponentials, we can straight away go and deal with our question. Now, if you are new to implicit differentiation, I would advise you to watch a video, okay, with a tag on top, and also the link is provided in the description. You can watch that video on implicit differentiation. Okay, so just to give you a background, if you have 2x y squared, okay, plus, I can add something else, let's say x squared, and then I say 3y cubed. You know, if you get to observe this case, you want to differentiate the function in respect to x, dy dx, of course, and then you cannot make y the subject. We call that implicit. You can't make something the subject, okay? So that's what we're trying to talk about in this case. So how do we differentiate it in case where we have an exponential function? Okay, so having an exponential function as we are given in this case, it is going to be very simple. So I know this is easier, that is easier. I'll focus more on the middle part first of all. We try to work out, which is e, right? So we have e to the power x to the power 3, y to the power 3, okay? So I emphasize to say the derivative of an exponential function with a base e, just multiply the derivative of the power to the original function. So just have to multiply the derivative of what? So the derivative of the power, which in this case is x3, y to the power 3, and then against the function itself, which is e, x to the power 3, y to the power 3, right? Okay, so we need to find the derivative of this. Okay, so we have a product of two different things. Okay, so how do we handle that? So this requires you to understand the product rule. If you've not, and if you don't know about product rule, you can also watch a video provided in the link. The link is in the description. Okay, so product rule tells us to say that if you have two functions multiplying, in this case we have got x to the power 3 and y to the power 3. I'll not write any formula here, I'll just go direct. So you can get any term to be the first term to start with. In this case, I'll start with I'll start with y to the power 3. And then I would have to multiply it against the derivative of the other part. So what is the derivative of x to the power 3? So I explained how to differentiate the functions, right? It's going to be 3x to the power 2. The power reduces by 1. The power multiplies the coefficient. Okay? Plus. So that's the product rule. Now, in the first part, we had started with y to the power 3. In this case, we're going to start with x to the power 3. And then multiply the derivative of what? The other part. So the other part in this case is y to the power 3. So if you differentiate y to the power 3, ignoring the fact that it's a y, you get 3y what? Squared. Now, the fact that it is y and we are differentiating in respect to x, would have to add dy dx. Okay, so simplifying all this, what do we remain with? So we'll have 3x squared y to the power 3 plus. So there equally we can say we have 3y squared x to the power 3 dy dx, right? Okay. So I can allow me to erase and create just some space there. Okay, at this point where we are, we've determined derivative of this guy, which is our power, right? So we can just quickly substitute in. Okay, so I'll go back to the original function. So dy dx. So of course, yeah. Okay, there's a 0 there. It's got to 0. So what is the derivative of x to the power 3? We talked about the derivative. It's what? 3x to the power 2. The power reduces by 1. Of course, the power first of all multiplies the coefficient 1. Now, the middle part, I said when differentiating exponential functions, you just have to differentiate the power. So the derivative of the power is exactly what we have on the bottom there. If you differentiate x to the power 3, y to the power 3. So we have 3x squared y to the power 3 plus 3y squared x to the power 3 dy dx. Now, you'd have to multiply everything there. Multiply by what? The original function itself, which is e to the power x to the power 3 y to the power 3. That's how you differentiate exponential functions. And then the derivative of a constant is just a 0. Okay, ultimately, this is what remains. Now, whenever we're dealing with implicit differentiation, after you perform the differentiation, you would have to make dy dx to be the subject of the function or expression that you get to have. So remember, we have got a function multiplying everything in the brackets, right? So we can basically get to expand. So we have 3x squared plus 3x squared y to the power 3, which is like the first term, multiplied by e, which is now coming from outside. And then again plus 3y squared x cubed times dy dx. And then now also times ex to the power 3 y to the power 3 equal to 0. So our goal is to make the part with dy dx a subject. So everything else goes the other side. So we remain with 3y squared x cubed dy dx. And then we have e to the power x to the power 3 y to the power 3 is equal to. So these two terms are going to the other side. They'll become negative, right? So we have negative 3x squared, negative 3x squared y cubed exponential x to the power 3 y to the power 3. Okay, so at this other point where we've moved now, it becomes easy to simplify it because we've almost made dy dx the subject. So all we just have to do is divide by this part and that part. Okay, so after doing that, what do we expect to have? So we can say our dy dx is going to be the left part, which is negative 3x squared minus 3x squared y cubed ex to the power 3 y to the power 3. And then we are dividing by what? This 3y squared x cubed, and then exponential x to the power 3 y to the power 3. Okay, so at this very point we've made dy dx to be the subject of the formula. So we've differentiated using the implicit differentiation. And then just one more question to make sure that everything we've done is stuck. Okay, so this is the second practice question. So we have 5y squared plus 2x plus e to the power 3xy. How do we get to differentiate this. Okay, so implicit differentiation, I'll go direct. 5y squared, that will give us 10. 2 times 5 is 10. The power reduces by 1, it will be y to the power 1. So the fact that we're differentiating in respect to x, y in respect to x, would have to multiply by dy dx. Plus. So 2x, this is just we're differentiating x, which we're interested in, to just be a 2. And then the other part where we have exponential. So I said when you're dealing with exponential, you'd have to first of all determine the derivative of the power. In this case, the power is 3xy. So we have products of two functions. Okay? We can say we have 3x and also y. So what is the derivative of 3x? It is a 3. And then what is the derivative of, we'd have to multiply by the other part, which is just y. Plus, what's the derivative of y? So the derivative of y to the power 1 is just going to give us 1 times dy dx. Why am I saying multiply by dy dx? Because we are differentiating y. So it's dy dx. And then once we multiply by the other part, which was 3x, right? It's that simple. So this is product rule. So the derivative that we have gotten, we're therefore supposed to multiply it against the original exponential function. So the original exponential function is e to the power 3xy. So at this point where we have reached, we are now at liberty of trying to make dy dx a subject. But before we could get to do that, we'd have to expand the other term. So we have 10y dy dx plus 2. So we have 3y multiplying by the exponential function to be 3y. So of our exponential function. And then this part as well, 3x multiplied by the exponential. And then of course not forgetting our dy dx equal to 0. So if you try to look at what we have, how many parts are having the dy dx? Those are the two parts, right? So those ones are going to remain on the left hand side. So obviously we have, I can directly factorize dy dx without wasting much of your time. So dy dx, and then remain if the first term is 10y, and then the other one is 3x exponential 3xy equal to, what is going the other side of just these two terms. So I have minus 2 minus 3y e 3x to the power y, or e to the power 3xy. So at the point where we've reached, we can just divide both sides. So ultimately we're just going to remain with 10y plus 3x e to the power 3xy. So that is basically how simple it is to determine the derivative of exponentials using implicit differentiation. Okay, so just like I said, if you want to understand more how we go about the implicit differentiation, check out the video in the description, and also understand more about the product rule to make things easier how you get to deal with this concept. So thank you very much for taking some time to watch this video.